Hi everyone, Rich Mokuolu from Partsimony. If you look in the crowd and see someone that looks just like me with a beard, is my twin brother in the crowd. But yeah, here to talk about decentralized manufacturing supply chains. It may not sound like a very sexy topic on the onset, but I promise you at the end of this topic, you might be fans, hopefully. But we'll start out with, again, water supply chains. And I'm going to just twist my body here so I can see the screen. But basically, here's how most products that you see today, whether it's the Apple Vision Pro, your car, your phone, this is how it's made and scaled, right? You have the engineering team that gets all the designs together, they test things out, they iterate a lot, whether it's a SpaceX rocket engine or whatever have you. Then they go into sourcing each individual component. Some of these components might be sourced internally, where you might manufacture it in-house, or you might go to other third parties like vendors. It might be in China, or it might be local in Brooklyn to manufacture individual components. And then you have your manufacturing facilities, and then you have to ship it to your customer, right? So when people talk about supply chains, a lot of people think Uber Eats, DoorDash, but it's really, really wide, right? It has to do with a lot more than just that. So now that we know about supply chains, I want you all to envision you making a motorcycle, right? So just envision a motorcycle in your head. You might just want to go on a nice leisurely ride. What does it actually look like? And so these are some of the key questions that you might want to answer if you're on the engineering team to make that motorcycle. So key questions like, where can you make design improvements, right? Where can you be more sustainable in your design? Because again, sustainability actually is not just a gimmick. It's really, really good when done well. And how can you leverage new manufacturing technologies like additive manufacturing, right, versus conventional manufacturing methods? And then for the supply chain teams, key questions such as where can you get better visibility within your supply chains? Because supply chains, as we all know, tend to be sometimes black boxes. Another thing is, where can you also be more sustainable, specifically around decentralization? Where can we have things manufactured local in Brooklyn versus overseas, which also saves a lot of time, money, and a lot of frustration. And then also, we're in a very dynamic ecosystem where there's a lot of geopolitical risk. I'm not going to get into geopolitical conversations over here, but all that to say is that you want to make sure you want to have a risk-resilient supply chain that's very adaptive. Now, all these questions are very fundamental and can be extremely difficult to answer. Now, before we go into kind of the solution, I just wanted to paint the picture of when we talk about decentralized networks for manufacturing, you'd often hear people talk about tiered supply chain networks. So a tier one could be, a Foxconn that makes the iPhone. So they do all the final assembly, test, and packaging. And then your tier two supplier does all the fabrication of the individual components. So it could be the enclosure of the iPhone, right, or the glass. And then your tier three are most of the raw material providers. So they may provide the aluminum to the vendor who's making the actual cases of the iPhone. So it can get very, very complex very, very quickly. You have very levels of fragmentation and concentration across each individual tier structure, and it changes by different product. So again, lots of complexity. And here's just a visual of a Tesla car, because why not? But just to show you how multi-different supply chains kind of tie together. So it can be a lot of chaos. Here is just a brief history lesson that we probably already know. Bob Dylan, times are changing, whatnot. But in the 70s, there was a big move around, low-cost country, maximizing shareholder value, maximizing profitability. You saw a lot of manufacturing drain go away from the US to low-cost countries like China, Southeast Asia. Also from a raw material perspective at the tier three manufacturer level, you see a lot of concentration around, Central Republic of Africa, for example, for raw materials or batteries. And that kind of changes over time. Also, when you look at supply chain structures, you can see a lot of fragmentation at the tier two and tier three level, with new manufacturing hubs such as India being a huge winner and Mexico being a huge winner, given the whole geopolitical landscape. Now, we like to break things out of Partsimony into certain like cycle phases, right? And so I know it seems like a really long time, a really short time, but pre-pandemic, there was things called tariff wars that we probably forget right now. But the whole theme over there was a lot of geopolitical uncertainty. And then we moved into the pandemic where it's all about shortages, right? Because a lot of tier twos and tier threes were kind of stuck or shut down. You couldn't really get your toilet paper delivered or your actual furniture delivered, which you might have to sit on a crate box for 7 months, like I did. And then when you go into the post-pandemic world, it's all about, how do you actually build an infrastructure that is adaptive, right? Because one thing that people didn't say during the pandemic is, thank God for my ERP software. It's just not a thing that people really said, right? And so what people need to focus on is how do we actually build an infrastructure that adapts to the prevailing needs? And again, to compound everything, the reason why this is really important that we address is about 80% of greenhouse gas emissions are actually tied within your actual supply chains. So in terms of impact, obviously recycling is really great, but if you can actually manage your supply chain more effectively, there's a significant impact that you can actually achieve. And so our whole thesis of Partsimony is bridging the gap between engineering and manufacturing supply chain activities, because again, it's not about having a reactive infrastructure, it's about having a proactive infrastructure where you're making better decisions up front and having an infrastructure that adapts to every prevailing demand. And so two key use cases here. One is around how do you actually make better product decisions, right? Again, if you're trying to make anything, whether it's a phone, a car, a medical device, right? How do you make sure that the decisions you're making in the design cycle is the right decision to where you're not spending a lot of CapEx and OpEx to learn a mistake and fix it later, right? And then the other thing, which has to do with centralization, decentralizations of supply networks, is how do you actually have a more risk-resilient supply chain to where you can find people maybe that could be local to you in Brooklyn or wherever you are in the world, right? And that's where basically Partsimony comes in. I'm going to breeze through this because I don't want to have a big ad over here. But what we do, and I think the AI kind of got in the middle of all this and jumbled it up. But basically, what we do is quite simple. We help unify the gap between engineering supply chain activities, help you do strategy in real time, and tie it down to the actual you build material design data. What Partsimony does really well is we go beyond taxonomy. So we go into the shape of an actual material or actual product and help you to identify the right supply chain structure for it. This is actually very important because in the middle of the pandemic, people were trying to manufacture ventilators. It took GM over 6 months. No shade to GM. It's very, very hard to do. But we actually supported a team out of MIT and produced ventilators within 2.5 months and local in Brooklyn. So it's very, very, very impactful. We also play nice with a lot of legacy ERP systems. We can also be a standalone ERP system. Again, a big thing tying down to centralization or decentralization of networks. Our philosophy is you need a hive mind to manage the chaos. So really intelligence really matters in terms of managing the entire network. And then we've achieved significant results because we're able to unify engineering supply chain context, which is extremely hard to do. Again, I'm going to just breeze through this. Great, awesome case studies. If you're interested, we can chat later about some of the actual case studies. But some of the key questions is, again, leveraging AI, building sustainability, managing your actual network. Future state. This is very interesting to us. So when you look at decentralized networks, we kind of see 4 themes. One is around factory automation, right? So when it comes to nearshoring, there's no secret that in the US, it's very costly to do things. Where we see actually that cost parity reduce at scale is you leveraging automation, right? So it's going to be a really huge unlock. Another thing is we have this thesis around adaptive factory hubs. So this is very different than an actual local supplier to you. It's basically looking at, there are going to be systems in place where it might be a car, for example, right? And you have like a whole seat assembly factory hub that's optimized for that. Or it's an electric EV motorcycle and you have like a battery system factory hub, right? So there is going to be some centralization within the decentralization overview, but it's going to be very, very important because economies of scale has not changed. And then artificial intelligence, I'm not going to touch on this because buzzword. And then industrial ecosystems. So our whole thesis on this is the real feature is there's really no end to the customer experience. From when you buy a product to when you use it or reuse it, it's a continuous feedback loop cycle that feeds on itself. So therefore, you as an engineer make better decisions, better product decisions, make better products, and a better customer experience. So it's basically just a virtuous cycle. And the key here is have the data to connect the entire customer experience to the actual manufacturing experience and to the engineering experience. And that's pretty much it. Happy to answer any questions afterwards.